this is section 9.2, the multiplication principle, permutations, and combinations. So the first thing we're going to look at are permutations and combinations. The P represents a permutation. C represents a combination. With a permutation, the order is important. And the calculator has a button. So the first one we have is 12P5. So we're going to hit the math button, go to probability, and we see permutations and combinations. So an example here would be we have 12 students in a club and we need to select 5 students for different offices. So for instance, president, vice president, treasurer, secretary, and representative perhaps. So how many ways can we fill those 5 positions with 12 students? And the order does matter because they have different responsibilities, different levels of power and whatnot. So there's 95,040 ways you can choose 5 or range 5 from 12 students. The next one is a combination. Hit math, or probability, combinations. So say we're going on a flight somewhere and we can bring some books with us, but we can only fit 3 in our bags. And of our 9 favorite books, how many ways can we choose 3? The order is not going to matter. We're just going to bring 3 books with us of our 9 favorite. So there's 84 ways we can do that. All right, and this last one kind of looks like an oddball with that 0 there. Every once in a while, you may get one of these problems. So let's see what we get. Put a 0 in there, we get a 1. Most of the time, you're going to have something other than 1, but again, I just want you to see the oddball ones. They do have formulas in my math lab for combinations and permutations, but you actually have to use a button that's on there. It looks like an exclamation point. It's called a factorial. So for instance, 5 factorial is 5 times 4 times 3 times 2 times 1. All right, let's look at this. We're going to use the multiplication principle, which is really easy to use. We have a home improvement store. They have 290 different kinds of glass wall tile, 20 colors of acrylic grout, 12 kinds of mortar trowels, and 19 different kinds of mortar. How many ways are there to buy one of each of these projects needed for a tile project? All right, so we have the tile we want to select, the grout, the trowel we are going to choose, and then finally the actual mortar itself. There's 290 kinds of tiles, 20 types of grout, 12 trowels, and 19 kinds of mortar. To find the total, we're just going to multiply these numbers together. And I'm not going to put the big calculator up just for straight multiplication. I am doing it on a calculator though. And that is a lot. So it's 1.3 million different ways you can combine those 4 items. Next, we have a menu. It offers 7 salads, 10 main dishes, and 6 desserts. How many different meals can we have consisting of 1 salad, 1 main dish, and 1 dessert? So we're going to multiply these together. And there's 420 total different types of meals you can select at this restaurant. The model of car you're thinking of buying has 6 different colors and 3 different styles. And how many ways can the car be ordered? So we have the color. There's 6 colors to choose from. And 3 different body styles. We multiply that together. There's 18 different ways we can order this car. All right. Next, we have a committee that has 7 Democrats and 8 Republicans. Democrats is 7, Republicans is 8. So the total number of people we have on this committee is 15. We want a delegation of 5, so we need to choose 5 to visit Small Island Republic. So how many different total delegations are possible, regardless of whether it's Democrat or Republicans? Okay, so it could be all Democrats, all Republicans, a combination of those. So we have 15 total people, and we're going to choose 5 to go to the island. All right, so hit math, go to probability, 15, choose 5. So there's 3,003 ways we can choose 5 of the 15 people. Part B wants to know how many delegations would have all Democrats. Okay, so we have 7 Democrats and we choose 5 at a time. How many ways can we do that? In the order, it doesn't matter. Nobody has a specific title or job. So there's 21 ways that delegation could have all Democrats. How many delegations would have exactly 4 Democrats and 1 Republican? So from the Democrats, we're going to choose 4. And then from the Republicans, we're going to choose 1. And you can just multiply it together like that, or you could evaluate 7C4 and then evaluate 8C1 and multiply the 2 numbers together. But you can put it in as one complete line if you want. It's up to you. If you feel more comfortable doing each one individually and multiplying the 2 results, that's fine. That'll work too. So there's 280 ways to choose exactly 4 Democrats and 1 Republican. All right, so now they want to know how many delegations would include at least 1 Republican. So we're going to take the total number of delegations, okay? That could be all Democrats, all Republicans, combination of the 2. We want to subtract how many have only Democrats, okay? So this is all possible. Minus the one that has all Democrats. All Democrats means there are left have at least 1. They could have 1, 2, 3, 4, or 5 Republicans. So we're subtracting out the one that has all Democrats because there are no Republicans in there. So let's subtract those 2 numbers. And that's 2,982 possible delegations that have at least 1 Republican. Okay, so part A minus part B. A lottery game requires that 7 different numbers are picked from 1 to 13. Okay, so the total you have to choose from is 13, and you want to pick 7. If someone picks all 7 winning numbers, the person wins 13 million. Find the number of ways to choose 7 numbers if the order is not important. So that's a combination. So that's going to be 13. Choose 7. So there's 1,716 ways to do that. And then how many ways to choose a seven numbers if order does matter? That is a permutation. So math, probability, NPR. And that's 13. And we need to arrange 7 at a time. That's a lot. Let me write this down. 8, 6, 4, 8, 6. I'm just going to put zeros. So it's 8.6 million ways if the order does matter. If there are 23 students in a fraternity, how many ways can a committee of 11 students be selected? It says committee. We're not saying they have specific roles or offices, so that it's going to be a combination. So that's 23, C11. And 1, 3, 5, 2078, 2, 3. So 1.3 million ways you can select that committee. I think this is the last one. Yep. This is it for section 9.2.